Got it?
I wrote mine the wrong thing.
Oh, you're serving other people? That's cool. Okay, ladies and gentlemen, what I do is I write this down either in your write down your homework, or what you can also just write down in a part section of your notes. As I'm just going to kind of explain everything exactly how we've been learning how to do all of our graphing techniques. So the main important thing I want to go through with this, when kind of transforming from cotangent and tangent from sine and cosine, the main important thing is I want you guys to remember we're doing everything exactly the same. I want to find the exact same information that we can find, just like we did with sine and cosine. So what I'm going to do is I'm going to write down, because when I told you guys about your homework, I said I would need to see all of this work, all this information, and on your quiz, I asked for all that information. So you guys got to get used to being able to say, okay, I know I need to determine what the amplitude is. I know I need to look at what the period is. I need to know what the x scale, or the distance between the critical points. And then also, I need to know the start and the end of our initial period. Because remember, these graphs go on and on forever. But what we like to do is graph our initial period. And then what we do is we replicate from that initial period. So when looking at the parent graph of our cotangent graph, if you guys look at that parent graph, because you remember we first started off with the parent graph of sine, then we looked at the parent graph of cosine, and then we learned how to graph from there. Well, by looking at the cotangent graph, there is no maximum height or minimum height. Therefore, the amplitude, which is the half distance between the maximum and minimum height.
Teachers, pardon the interruption again. Just for clarification, any students that are involved in the Wednesday challenge day is to go ahead and report to the auditorium at this time. Thank you.
Okay. So now the next thing we have is we're looking at period. And if you guys remember, when we were dealing with period with sine and cosine, it was 2 pi divided by b. And I kept on reminding you, 2 pi divided by b, 2 pi divided by b. Well, now, when you look at the period of a cotangent graph, the parent graph of a period of a cotangent graph is only now pi. So it's going to be pi divided by b, which in this case, I have pi divided by 1/2. And then remember, to get the 1/2 off the bottom, you multiply by the reciprocal. And in this case, our period is going to be 2 pi, because we actually have an transformation in our graph, or dilation, or our extension of our period, something like that. Now let's go and look at our x scale. Now, before, we always remember our x scale was always take your period divided by 4. That's all you guys have to do. Take your period and divide it by 4. Now, a lot of times we like to still do that for our x scale, because there's a way of graphing tangent and cotangent to get a very descriptive graph. We can see the curve line a lot better by using 4 important points. However, for tangent and cotangent, I'm just going to kind of go through this a little bit quicker than we can. And I'm just going to have you guys now divide your critical points by 2. So I'm just going to take 2 pi and divide it by 2. Therefore, your x scale, for the way that I'm going to have you guys do it, is just going to be pi. All right? And now the next thing is your start and your end. When looking at a cotangent graph, our initial period starts at 0 and ends at pi. At the period, for the initial period for a cosine graph and sine graph, started at 0 and ended at 2 pi. So what we're going to do is we're going to take whatever's inside of our function, and we're going to set it equal to 0. We're going to take whatever's inside of our function and set it equal to pi. Therefore, when I solve for x, I get x equals 0 and x equals 2 pi. All right, so let's go and take a look at how it's going to graph. So we start at 0, and then we say our x scale is pi. And we could also go in the negative direction. Okay, this is also going to be your y-axis. All right, so that's what we have so far, right? So how does the graph look like? What does cotangent look like? Well, to find out what cotangent looks like, in your book, and what we'll explain in another video, is looking at the parent functions. You guys have to know what the parent functions are. All right. The main important thing you guys need to understand is on cotangent, the start and the end of a period are actually part of your asymptotes. So therefore, this at 0 is actually going to be an asymptote. At 2 pi, I'm also going to have an asymptote. And at negative 2 pi, I'm going to have an asymptote. And the reason why you're going to have asymptotes there is, again, if we looked at kind of plotting the points of each one of those graphs, you'll see that these would be undefined values for your function. All right? So if you were to plug in cotangent of 0, that's an undefined value. You can look at your unit circle and say, what's the tangent of 0? And you understand that that coordinate point, you're going to have 0 as your denominator. All right, so now what does that graph look like? Again, we have to go back to seeing what is our graph? What do cotangent graphs look like? Well, the reason why I told you to do 2 important points, because if here's my start, here's a critical point, and then here's our other critical point, which is our asymptote. So what is this going to be as your critical point? This is going to be your intercept, as this is going to be an intercept as well. So when we did critical points with 4, they're not really critical points, but they're better ways to graph it. Because what you can do is if you did 4 critical points, you could find the values at these 2 points, and it'd help you graph the curve a lot better. I'm not really concerned right now. I just want you guys, for that, I want to be able to, for you guys to be able to get this information and then to understand what the cotangent curve looks like, which, since it's an asymptote, it's going to be approaching my asymptotes. And on a cotangent graph, the parent graph rises left and falls right. So there is 2 periods graphed for the cotangent function. Yes? Yeah, I'll show you in a different video what it looks like, how the parent graphs look. Okay? Cool. Yeah, I'll show you guys right now. I mean, it's in your book. And